Good morning, dear students. I hope all of you are fine. In a previous lecture, I have discussed reflexive relation, symmetric relation, and transitive relation, and some problems based on these type of relation from exercise 1.1 with you. Now, in this lecture, we will discuss injective function, surjective function, bijective function, one-one mapping, many-one mapping, onto mapping. As I have already told you the definition of these type of mapping, so I will come directly on the problems based on these mappings from exercise 1.2. See, question number 1 from exercise 1.2. Show that the function f from r star to r star defined by f of x is equal to 1 upon x is 1 1 and onto. We have to show that this mapping f is 1 1 and onto, where r star is the set of all non-zero real numbers. मीन्स बेटा r स्टार में ज़ीरो को छोड़कर सारे रियल नंबर्स आ रहे हैं, all the numbers except 0. So let us see the solution of this question. How we will prove that this function is 1 1. To prove a function is 1 1, we have to show that if two real numbers have same images, then these numbers must be same. So let x and y be two non-zero real numbers such that their images are equal. Means f of x is equal to f of y. So apply the definition of fx. It is 1 upon x is equal to 1 upon y. So after simplifying, it gives x is equal to y. Means equal points have equal images. And this is the definition of injectivity of a function. So this shows that f is 1 1. Now to show f is onto, we have to show that each non-zero real number has a pre-image. Okay, so to show f is onto, let y be a non-zero real number. So if y is a non-zero real number, then 1 upon y must be a non-zero real number. And if we find the image of 1 upon y, f of 1 upon y, by the definition of this 1 upon y, by simplifying we will get y. So for each non-zero real number, we have another non-zero real number 1 upon y such that f1 upon y is equal to y. Means each real number has its pre-image. Okay. If I will write f of x is equal to y, what does it mean? It means that the image of x is y and x is the pre-image of y. I again repeating my statement. Y is the image of x and x is the pre-image of y. Okay, y is the image of x and x is the pre-image of y. So in this way we can say that f is 1 1 and onto, right? So this function is 1 1 and onto both. This is the way how can we show that a function is 1 1 and onto. Now next part of the question. Next part of the question, is the result true if the domain r star is replaced by n with codomain being same as r star. Okay, अब हमने डोमेन को बेटा रिप्लेस कर दिया सेट ऑफ नेचुरल नंबर्स के साथ, तो क्या होगा? सेट ऑफ नेचुरल नंबर के साथ अगर आपने डोमेन को रिप्लेस कर दिया तो इन 1 1 में कोई प्रॉब्लम नहीं आएगी. 1 1 ओके, फंक्शन 1 1 तो रहेगा, लेकिन अब ऑन टू होगा या नहीं होगा? बेटा अगर यहाँ पे नेचुरल नंबर्स का सेट आ गया, ठीक है, और इधर आपका नॉन ज़ीरो रियल नंबर्स का सेट है, यहाँ पे मैंने गलती से r प्लस यूज़ किया है, बेटा प्लस नहीं होगा, यहाँ पे स्टार होगा, r स्टार. ओके, तो इस गलती को आप ठीक कर लीजिएगा. तो हर नॉन ज़ीरो रियल नंबर के लिए क्या प्री इमेज मिल जाएगी? क्या बेटा आपको कोई ऐसा नंबर, कोई ऐसा नेचुरल नंबर मिलेगा जिसकी इमेज 2 आ जाए? बिकॉज 2 इमेज बनेगी वो बनेगी 1/2 की. There exists not any element, there does not exist any element in n such that f of x is equal to 2. क्योंकि अगर बेटा f of x को 2 करना है तो x को 1/2 करना होगा, और x 1/2 नहीं हो सकता because 1/2 is not a natural number. So we don't have any natural number whose image is 2. मतलब बेटा आपको 2 की प्री इमेज नहीं मिलेगी, और अगर एक भी पॉइंट की अगर आपको प्री इमेज नहीं मिलेगी मीन्स द फंक्शन f is not onto. For the function to be onto, each point in the codomain must have a preimage. If there exists any point which do not have a preimage, then the function is not onto. Okay, now let us see the next problem. A function f from the set of integers to set of integers defined as f of x is equal to x square. Now let us see the let us see the injectivity of this function. Beta, under this function f of 2, the image of 2 is 4 and image of minus 2 is also 4. 2 ka square is equal to 4 and minus 2 ka square is also equal to 4. So two different points have same image, so f is not 1 1, because for 1 1, for the function to be 1 1, different points cannot have a same images. Okay, now see the surjectivity of the function. Surjectivity means to check the function is onto or not. But dear student, there does not exist any integer such that whose image is 2. Okay, means 2 has not pre-image. कोई भी ऐसा इंटीजर आपको नहीं मिलेगा जिसकी इमेज 2 हो जाए, या हम इसको दूसरे टाइप से ऐसे भी कह सकते हैं 2 की आपको कोई भी प्री इमेज नहीं मिलेगी, क्योंकि 2 इमेज बनेगा स्क्वायर रूट ऑफ 2 की, एंड स्क्वायर रूट ऑफ 2 इज नॉट एन इंटीजर. स्क्वायर रूट ऑफ 2 इज एन रैशनल नंबर. ओके, irrational number, sorry. So the function is not surjective. Now see the next problem. If we define the same function on the set of natural number, then what will be the conditions? Suppose x and y are two natural numbers such that their images will be same. F of x is equal to f of y. Apply the definition of fx. So x square is equal to y square. Taking the square root of both sides, it gives x equal to y. Means if the points have same images, then these points must be same. हमने यहाँ पे बेटा नेगेटिव साइन को क्यों एक्सक्लूड किया? क्योंकि हम यहाँ पे नेचुरल नंबर्स के सेट की बात कर रहे हैं, और नेचुरल नंबर्स कभी भी नेगेटिव नहीं होते. नेचुरल नंबर्स आर व्हाट? 1 2 3 4 5 एंड सो ऑन. ओके, so f is an injective function. See, we have the same function, but if we change the domain and codomain, then it affects on the injectivity and surjectivity of the function. Here the function is not injective when the domain is the set of integers, but when the domain is the set of natural number, then it is injective. Means domain and codomain effect on the surjectivity and injectivity of the function. f is not surjective. सर्जेक्टिव के लिए बेटा सेम प्रूफ है जैसे आप ऐसे यहाँ पर प्रूफ किया हुआ है. आपको कोई भी नेचुरल नंबर ऐसा नहीं मिलेगा जिसकी इमेज 2 हो जाए. 2 इज़ अ नेचुरल नंबर, लेकिन इस साइड में लेफ्ट में आपको कोई भी ऐसा नेचुरल नंबर नहीं मिलेगा कि f of x 2 के इक्वल हो जाए. ओके, सो f इज नॉट सर्जेक्टिव. नाउ इफ वी define the same function on the set of real numbers, then check the injectivity and surjectivity of the function. 2 is a real number and minus 2 is a real number, but 2 is not equal to 2, but the image of 2 and minus 2 are same. Okay, means different point have same images. This shows that the function is not 1 1, right? Now check the surjectivity of the function. Take a real number in the codomain R. Let x belongs to R such that f of y is equal to x. Why the definition of fy equal to y square is equal to fx, so y is equal to under root x. So if x is a real number, then square root of x is also a real number, and if we find the image of square root of x, then it becomes x. Means for each real number, x has a pre-image, and what is its pre-image? Under root x. Means each real number in the codomain has a pre-image. Okay, so the function is onto. For the function to be 1 1, different point have different images, and for the function to be onto, each point of the codomain has its pre-image. Okay, in other words, we can say that अगर आपको कोई भी पॉइंट को डोमेन में ऐसा मिल गया जिसको अपनी प्री इमेज नहीं मिलेगी तो फंक्शन बेटा सर्जेक्टिव नहीं होगा. इफ देयर एग्जिस्ट अ सिंगल पॉइंट इन द कोडोमेन विच हैज नॉट इट्स प्री इमेज इन द डोमेन देन द फंक्शन f is not surjective. Okay, to show the surjectivity of the function we can also show that codomain is equal to range. If codomain is equal to range then the function is onto. If codomain is not equal to range then function is not onto. Similarly we can check the injectivity and surjectivity of the function f of x is equal to x cube in fifth part, greatest integer function. Similarly, fifth part of this question can be done. Okay, now let us discuss the question number 3. What is the question number 3? Prove that the greatest integer function f from r to r given by f of x is equal to greatest integer function x is neither 1 nor onto. First of all, we have to understand the definition of greatest integer function. The greatest integer function is that ग्रेटेस्ट इंटीजर बट नॉट ग्रेटर देन एक्स. मीन्स बेटा जो ये जो ब्रैकेट बना के आपने एक्स लिखा हुआ है इसकी वैल्यू जो फाइनल वैल्यू आपकी आएगी वो कभी भी एक्स से बड़ी नहीं आएगी और हमेशा जो भी वैल्यू आएगी वो इंटीग्रल वैल्यू आएगी. सो इट इज कॉल्ड ग्रेटेस्ट इंटीजर फंक्शन. ग्रेटेस्ट इंटीजर बट नॉट ग्रेटर देन एक्स. सो इफ वी कैलकुलेट एफ ऑफ 1.5, इफ वी फाइंड द इमेज ऑफ 1.5 अंडर दिस फंक्शन, सो 1.5 तो आपको बेटा ऐसा इंटीजर बताना है जो 1.5 से बड़ा ना हो लेकिन अपने आप में सबसे बड़ा हो. सो इट विल बी 1 मीन्स क्लोजेस्ट इंटीजर बट नॉट ग्रेटर देन दिस नंबर. 1.5 के सबसे क्लोज कौन होगा? दो इंटीजर्स होंगे 1 और 2, लेकिन हम लोगों को हमें 1.5 से बड़ा इंटीजर नहीं लेना है. सो वी विल टेक 1 क्लोजेस्ट इंटीजर. इन अदर वर्ड्स वी कैन से दैट closest integer to the given number but not greater than that number. Okay, similarly if we calculate the image of 1.6 then it becomes it is also 1. So we have two different numbers which have same images. This shows that the function f is not 1 1, right? Now to check it, here the codomain is the set of real numbers but the function gives only integral values, means range set is the set of integers. So range is not equal to codomain. रेंज कोडोमेन के इक्वल अगर बेटा नहीं होगी तो फंक्शन ऑन टू नहीं होगा. मीन्स अगर आप यहाँ पे कोई भी नॉन इंटीग्रल वैल्यू लोगे, सपोज करो आपने यहाँ पे वैल्यू ले ली 1.5, तो उसकी प्री इमेज आपको यहाँ पर नहीं मिलेगी. तो अगर आपको ये शो करना है कोई भी फंक्शन ऑन टू नहीं है तो आप ये भी शो कर सकते हो कि द कोडोमेन इज नॉट इक्वल टू रेंज. Here range is the set of integers and codomain is the set of real numbers. Now let us discuss the next problem. Question number 4. Question number 4. Show that the modulus function f from the set of real numbers to set of real numbers given by f of x is equal to modulus of x. Modulus means positive value. Okay. So here the codomain is set of real numbers but modulus function gives always positive values, means positive real numbers. Codomain is whole real number, all the real numbers, but range is positive real numbers, means codomain is not equal to range. And if codomain is not equal to range then the function is not surjective. Now check the injectivity of the function, or I can say check the function to be 1 1 or not. F of minus 2 is equal to 2. If we find the image of minus 2 it is 2, and if we find the image of 2 it is also 2. Means we have the different points 2 and minus 2 which have same images. So the function is also not 1 1. फंक्शन यहाँ पे 1 1 भी नहीं होगा क्योंकि आपको दो डिफरेंट नंबर ऐसे मिल गए जिनकी इमेज सेम है. Let us see the next problem. Show that the signum function f from the set of real numbers given by this definition, it is neither 1 1 nor onto. It is clear that the range set contains only 3 points 1, 0, minus 1, and codomain is the set of all real numbers. Okay, so codomain is not equal to range. See, range is what? 1, 0, minus 1, and codomain is R. These are not equal, so f is not onto. Now to check the function to be 1, 1, we will take 2 points. If we find the image of 2 under this function, under this mapping f of 2, then 2 is greater than 0, so it gives the value 1. And if we find the image of 3 under this mapping, 3 is also greater than 0, so its value is 1. Means we have get 2 points, 2 different points which have same images. 2 and 3 are different, but they have same images 1. So f is also not 1, 1, because different numbers have the same images. For the function to be 1, 1, different points or different numbers, if we are talking about the real number, then we can say that different real numbers have different images for the function to be 1, 1. So f is not 1, 1. Okay. Now let us see the next problem. Here we have two sets A 1, 2, 3 and another set B 4, 5, 6, 7, and we define a mapping F 1, 4, 2, 5, 3, 6. Here different point have different images. Okay, so each element is the image of unique element. कहीं भी ना तो बेटा सेकेंड स्लॉट कहीं पे रिपीट नहीं हो रहा. अगर 4 एक बार राइट में प्लेस पे आ गया तो और किसी पेयर में 4 नहीं आ रहा है. इसका मतलब फंक्शन 1, 1 हो गया. मतलब 4, 5, 6 ये केवल और केवल एक एक सिंगल यूनिक एलिमेंट की इमेजेस है. सो फंक्शन इज 1, 1. बट कैन यू टेल मी दैट द फंक्शन इज ऑन टू और नॉट? Function is not onto, because range of f is 4, 5, 6 and codomain is 4, 5, 6, 7. Codomain is not equal to range, so the function is not onto, because 7 is a point in the codomain which has not a pre-image. 7 बेटा एक ऐसा पॉइंट है कोडोमेन में जो किसी की भी इमेज नहीं बना. इन अदर वर्ड्स वी कैन से दैट 7 को कोई भी प्री इमेज नहीं मिली. ओके, सो द फंक्शन इज नॉट ऑन टू. नाउ लेट अस डिफाइन द नेक्स्ट फंक्शन ऑन द सेट ऑफ रियल नंबर्स f of x is equal to 3 minus 4x. To show the injectivity, let us take two real numbers x1 and x2 which have same images. So f of x1 is equal to f of x2. Apply the definition of f. 3 minus 4x1 is equal to 3 minus 4x2. After some normal simplification, we will get x1 is equal to x2. Means if the images are same, then points must be same. This shows that the function f is 1, 1. Now to check the surjectivity of the function, we take any real number in the codomain. Okay. Let y be a real number such that f of x is equal to y. 3 minus 4x is equal to y. After simplifying, we will get x is equal to 3 minus y upon 4. Now, if y is a real number, then 3 minus y upon 4 is also a real number. And if we find the image of 3 minus y upon 4, then it will be y. Means each real number or each point in the codomain has its pre-image. So the function f is onto, right? Now we will see the next problem. F from the set of real numbers to set of real numbers defined as f of x is equal to 1 plus x square. Here I have left one thing, x square plus 1. See, f of x is equal to 1 plus x square. तो इस मिस्टेक को बेटा करेक्ट कर लेना. ओके, नाउ लेट अस फाइंड द इमेज ऑफ 2 and minus 2 अंडर दिस फंक्शन. f of 2 is equal to 1 plus x square, so 1 plus 2 का square is equal to 5. And if we calculate f of minus 2, it is also 5. So f of 2 is equal to f of minus 2, but 2 is not equal to 2. Means different point have same images. This shows that the function is not 1, 1. Now let us calculate the range of f. Let us see what will be the range of f. In range of f, x square is also positive. Now if we add some positive number to 1, then it will give the value greater than 1. Is it clear? Again I am repeating my statement. X square always takes the positive value for all real numbers, okay, and if we add some positive real number to 1, then it gives the value greater than 1. So range contains all the numbers greater than 1. So range is an interval, semi-closed interval from 1 to infinite, and codomain is real number, means range is not equal to codomain, right? So the function f is not onto. Eighth question is a very simple question, so you can understand it yourself. Now see the next question, ninth question. In ninth question, we have defined a function f on the set of natural numbers such that, okay, now first of all we will check the injectivity of the function, okay. If, and one thing more, if the function is 1 1 and 1 2 both, or I can say if the function is injective and surjective both, then the function is called bijective function, okay. If the function is injective and surjective both, or if the function is 1 1 and 2 both, then the function is called bijective function, right? Let us find the image of 3 under this mapping. 3 is an odd number, so we use this definition, n plus 1 by 2, 3 plus 1 by 2, 4 by 2, and it gives 2. And if we find the image of 4 under this mapping, 4 is an even number, so we use this definition, 4 upon 2, it gives 2. Means we have two different points, 3 and 4, which have same images, so the function f is not 1 1, okay. Now we will check the surjectivity of the function. For surjectivity of the function, let us take a point in the codomain, okay. Let x be a natural number, then we have two cases, either x is an odd number or x is an even number. So if x is an odd number, then 2x minus 1 is also a natural number, and if x is odd, then 2x minus 1 is also an odd number. And let us find the image of 2x minus 1. Apply this definition. Here we replace n by 2x minus 1. So 2x minus 1 plus 1 upon 2, and it gives x. Means for each odd natural number x, there exists a odd natural number 2x minus 1 such that f of 2x minus 1 is equal to x. Now if x is an even natural number, then 2x is also an even natural number. Twice of a even natural number is also a even natural number. And if we find the image of 2x under this mapping, then it becomes x. Means for every natural number has a pre-image. Every natural number has a pre-image, so the function f is onto, right? Now let us see the next problem. Problem number 10. In problem number 10, we have taken two sets. The set A is what? The set of all real numbers except 3, and the set B is the set of all real numbers except 1. And we define a function f such that f of x is equal to x minus 2 upon x minus 3. Okay. Now we will check the function is 1 1 and on 2. For the function f to be 1 1, let us take two points in the set A such that f of x1 is equal to f of x2. F of x is equal to f of y. You can also take x1 and x2. Simple, apply the definition of f of x and f of y. Now cross multiply and simplifying, we will get x is equal to y. So if the images are same, then the points are same. Okay. So this shows that the function f is 1 1. Okay. Now ओके, यू कैन आस्क वन मोर प्रॉब्लम. आप एक चीज़ पूछ सकते हो, सर हमने इसमें इन दो पॉइंट्स को एक्सक्लूड क्यों किया, डोमेन में से 3 को एक्सक्लूड क्यों किया, को डोमेन में से 1 को एक्सक्लूड क्यों किया. तो सबसे पहले मैं आपको इसका रीज़न बताता हूँ कि डोमेन में से 3 को एक्सक्लूड क्यों किया. क्योंकि बेटा अगर आप डोमेन में 3 ले लोगे तो यहाँ पे जैसे ही आप 3 की इमेज को कैलकुलेट करोगे तो आपके डिनोमिनेटर में 3 - 3 बिकम 0. एंड वी and if we divide any quantity by 0, then it becomes infinite. Okay, and infinite doesn't exist. इसलिए हमने 3 को एक्सक्लूड किया, क्योंकि एट द पॉइंट 3 द वैल्यू इज infinite. Infinite means the function becomes undefined, so that point must be excluded. अब इसका आंसर आपको बाद में मिलेगा कि हमने कोडोमेन में से 1 को एक्सक्लूड क्यों किया. So let us check the surjectivity of the function. To check the surjectivity of the function, take a point here y in V such that f of x is equal to y, f of x is equal to y. Now apply the definition. X minus 2, x minus 3 is equal to y. Now after some normal steps, some normal calculation, we will get x is equal to 2 minus 3y upon 1 minus y. See, y कहाँ से आपने लिया है? Y belongs to what? Y belongs to B. And if we include 1 in V, then this value becomes infinite. Okay, so for this value must be finite, y must be not equal to 1. This is the reason we excluded 1 from the codomain. For the rest of the numbers, it is a real number. y अगर 1 के अलावा कोई भी रियल नंबर आप फिल करोगे तो ये हमेशा रियल नंबर ही मिलेगा. ओके, सो ईच point in V has a pre-image. Each point in V has a pre-image. This shows that the function f is onto, right? Now let us discuss the next problem. We define a function f on the set of real numbers such that f of x is equal to x raised to the power 4. Now let us calculate the image of some real numbers under this function, under this mapping. F of 2 is what? 2 raised to the power 4, it is 16. F of minus 2 is what? Minus 2 raised to the power, it is also 16. So we will get two different points, 2 and minus 2, which have same images. This shows that the function is many one. Okay, is it clear? So the function is many one. Now check the surjectivity of the function. X raised to the power 4, even power of a real number always gives the positive value. Okay, it means that the range set contains only positive real numbers, but codomain is the set of all real numbers and range set is the positive real numbers. I am again repeating, range set is the positive real numbers and codomain is the all real numbers, means codomain is not equal to range. This shows that the function f is not onto. See, नेगेटिव पॉइंट कभी भी रेंज में आएगा ही नहीं. ओके, नाउ लास्ट प्रॉब्लम ऑफ दिस एक्सरसाइज इज क्वेश्चन नंबर 12. अ फंक्शन f defined on the set of real numbers f of x is equal to 3x. To check the function is 1 1 and onto or not. To check the injectivity, same process. Take two different real numbers such that their image is same, fx is equal to fy. Using the definition of f, 3x is equal to 3y, it gives s equal to y. Means if the images are same, then points must be same. So f is 1 1. Now to check the surjectivity or to check the function is 1 onto or not, let us take a real number y. If y is a real number, then y upon 3 must be a real number. And if we find the image of y upon 3, then it is y. Means each real number y has a pre-image. And what will be its pre-image? Y upon 3. I am again repeating this statement that y is the image of y upon 3 and y upon 3 is the pre-image of y. Y is the image of y upon 3 and y upon 3 is the pre-image of y. So each point have a pre-image. This shows that the function f is onto. In this way, exercise 1.2 is completed. In the next lecture, we will discuss the composition of two functions. Okay, thank you.